everyone. I'm George Hadjidemetriou. I'm a postdoctoral research associate at the University of Cambridge, but the work I'm going to present today conducted when I was doing my PhD at the University of Cyprus. My PhD was a collaboration between University of Cyprus, Cambridge University, and Georgia Tech. And the topic of my presentation is pavement condition and traffic indices for prioritizing road maintenance. This is the outline of the presentation. First, I'm going to present a method for automated detection of distressed pavement areas. Second, I'm going to present another vision-based method for vehicles detection, classification, and counting. And then I'm going to combine those two in order to develop a new index for prioritizing road maintenance. Roads is the largest piece of infrastructure. 40% of Earth's population uses roads for at least 1 hour per day. As we all know, they contribute to mobility and productivity. Despite their criticality, in many cases, their condition is very poor. Recent reports in the UK and in the US showed that the evaluation score is close to D, which means failure. Poor condition can lead to traffic rerouting, congestion, reduced productivity, and mobility. These are the basic steps that departments of transportation follow in order to assess their pavements. They first collect data, they detect and classify defects, then they evaluate the severity and extent of defects, and based on this information, they calculate some condition indices, which then show what type of repair action they should follow. They do that using semi-automated or manual techniques. First one is characterized by high accuracy, since these vehicles are equipped with several sensors and they can move at highway speeds. However, they are extremely expensive, and there is no transportation authority that can afford them for their entire network. And that's why they mainly use manual inspections, which are, of course, time-consuming. They pose safety risks for the inspectors, and they are subjective since they depend on the experience and the opinion of the inspectors. So our objective was to develop a low-cost, effective method for rating pavements and prioritizing their maintenance. First step was to identify what types of defects are we looking for, then develop an automated method for detecting the distress areas. We believe that maintenance prioritization should not be a matter only of pavement condition, but also of traffic. Because, for example, if a road is used by no one, but is in a very bad condition, it should not be prioritized over another road which is in a slightly better condition, but it's critical and it's used by many people. So the combination of the automated distress detection method and the automated traffic monitoring will give us the maintenance prioritization index. First method, I'm not going to get into detail because we don't have the time. You can ask me later if you have any questions. We first collected some videos. From those videos, we extracted frames along with their location. We use some computer vision-based techniques to treat blurry areas and remove shadows. We transform the images into grayscale because the shades of the road are normally gray, so we don't need the RGB information. And then we calculated entropy, and based on the entropy value, we classified frames into distressed frames and healthy frames. How is entropy related with road condition? We observed that healthy pavements, they are characterized by similar shades of gray, while distressed pavements are characterized by several different gray shades. So the worse the pavement condition is, the higher the entropy value is. We use this equation, is Shannon's entropy, This is an example of a collected video. The y-axis show the entropy value, the x-axis show the number of the frame extracted from a video. You can see some annotations of the existing defect types. Everything above the threshold value is classified as distressed pavement. Everything below is classified as healthy pavement. These are some examples of the extracted frames. As you can see, for example, in the last one where we have alligator cracking and the pavement is in a very bad condition, the entropy value is the highest. These are developed heat maps from a specific road that we inspected. With red color, you can see the distressed areas. A few information about the experiment. Firstly, we position a GoPro camera at the backside of my car. The average speed of the car was 25 kilometers per hour moving in a city. We inspected a total length of 10 kilometers. We selected a GoPro camera because it's wide angle and it can cover the entire lane, and it also gives you the GPS information. The results were close to 89% of accuracy. And we are moving to the second method for vehicles detection, classification, and counting. We had to classify vehicles into 3 different categories, and the reason is that different size of vehicles, they cover different space in a road, and they also deteriorate pavement in a different way. So according to the literature, we classify 2-wheeled vehicles, light vehicles, and heavy vehicles. This is the methodology. Again, I'm not going to get into detail. We collected videos, we initialized the foreground, and we segmented the foreground from the background. We applied some morphological operations to improve the results. Vehicles were detected, classified, and counted. They were classified based on the number of connected pixels moving from one frame to another. In the first row, you can see a 2-wheel vehicle, like a motorbike, then a light vehicle, and then a heavy vehicle. As you can see, they cover different space in the image. First column is the initial results. Second column is after applying morphological operation. How this works is that, for example, if you have a pixel and it's classified as positive, and all of the surrounding pixels are classified as negative, this pixel is going to be transformed as negative as well. And that's how the results are improved. Okay, this is the final display of the detected vehicles. A few information about the experiment. We use a normal smartphone positioned at a height of 9 meters to collect the videos. The precision was close to 90%, recall 94%. Then we tried to develop some new indices. First one, pavement condition index, second one, traffic index, and to combine those two to give us the maintenance prioritization index, we transformed the entropy value into a scale from 1 to 100, conducting normalization, and then we compared our method with 2 widespread indices. They are called PACER and PSCI, and as you can see, when these indices decrease their value, our index increase its value, and they are directly connected. For example, when we have photo number A, where you have a healthy pavement, it's rated by 1 by our index, and then last one, which is the worst condition, it's rated by 100. Then we try to classify some categories of the index and identify what type of defects might exist in every category and what type of severity. L means low severity, M medium, and H high severity. We followed a similar procedure for identifying the traffic index, again from 1 to 100. 1 is a minimum number of vehicles that can pass through a single lane over an hour. 100 is the maximum. We had to use some weights for the vehicles because, as I said before, a motorcycle and a car is not the same thing. Again, from the literature, we used the mean values. We selected 0.3 for two-wheel vehicles, 1 for light vehicles, and 2.3 for heavy vehicles. This means that 3 motorbikes are like 1 car. And then we tried to combine the 2 indices, pavement condition index and traffic volume index, to give us the final maintenance prioritization index. Transportation authorities can give different weights to these indices according to their needs. To conclude, we believe that we have promising techniques for identifying pavement distress areas and for classifying and counting vehicles. These things have already been published in journals, and even if I have finished my PhD, we just got a 3-year project to continue this work. But the maintenance prioritization is work in progress. We need to improve that. We should take into consideration more factors like the criticality of the road. For example, if a road connects an isolated area with a city, should have like a height weight. We should consider the number of lanes, life cost analysis, and some other things. We plan to use more sensors, not only cameras, to combine different techniques so that we will be able to classify every defect type. And then we're gonna put all of these sensors in embedded systems that they will be positioned in vehicles moving around cities, collecting data, so that we will be able to assess entire road networks to improve their condition and enhance the user's safety and comfort. Thank you.